Again, yeah. So last session was all about strings. So as I said, there was 40, and they're all numbered in this class, starting with concat there and ending with replace there. And there's a few more to look at today. But that was the thing to bear in mind. Strings are not mutable; they're immutable. So whenever you do string manipulations, it creates a new object. And Java, so that could, if you're doing a lot of string manipulations, that could potentially be a lot of memory using up creating objects, and Java mitigates that to a certain extent by maintaining that part of memory called the string pool, which we talked about in the last session. But still, even with the string pool, you potentially, if you know up front you're going to be doing a lot of manipulation of strings, there's another class that's probably a better candidate to use than the string itself, and that's StringBuilder. So I've got this StringBuilder tester class here which demonstrates that. And what this does is it is mutable. So in other words, you can change the value of it. So strings are immutable, but string builders aren't. So string is just like it holds its own representation of a string inside itself, and it keeps, it maintains that internally rather than creating new objects on a string pool. Just to demonstrate, if we've got a string. This is to compare it with a string. So we're starting with a string. We're not doing string builder yet. So a string just starts with an empty string like that, and just a bit of revision of a for loop here. So we're doing an old-fashioned style for loop, and this just shows, like, normally when you do a for loop, you use int I like that. It's just convention. You would use int I to initialize it, but just for a change, we're using a char to do it, and we're starting at A, and the condition is that while that char is less than or equal to Z, and then for each incrementation of the loop, so for each passing of the loop, increment that. So in other words, we're going to be incrementing from A to Z rather than we normally would do it numerically, but it's just to show a different way of doing it. And we'll say for each increment of the loop, we will say assign. If you remember with strings, you can use the plus operator or the compound operator like that, and we'll assign the value of whatever current is to the string. We'll append it effectively, and so we're going to print the value out each time we pass through the loop there. And this, as I said, is with strings. Nothing about string builders yet. So if we run that, there we go. Just try and move this up a little bit, and there we see. So each passing of the loop, we're building that string up like that. But because strings are immutable, the very act of doing that means that we created 27 objects on the heap, and most of them are almost immediately eligible for garbage collection, so it seems very wasteful. 27 because we create the original string there, and then we pass through this 26 times for every letter of the alphabet. So we can do it with a string, but it's quite wasteful to do it if you're doing lots of manipulation, quite a lot of objects being created. So this is where we can see how we do it with this string builder class. So here, now string builder, it doesn't have those magical properties of a string. It doesn't have a pool or anything like that, and you can't use the plus operator in it. This is much more like a normal Java object. So in normal Java objects, the only way you can get them is by creating a new. So string builder equals new string builder. So we've got a new object on the heap. So we've got one object on the heap. And then very, very similar to before, but exactly the same loop there, but instead of doing plus equals like a concatenation of strings, we're using the append method of string builder. So again, I think I've numbered these again like before. So all the methods we're going to look at in string builder, I've numbered them. So the first one to look at is append, and like you said, Richard, that's very similar to the concat method of a string. So this time, let's do it this way, and there's another system out there just to tell you what this is. So there's a system out there, so just print those, see what we get there. So the first one was building the alphabet using string objects creates 27 objects. That's what we did first of all, and there they are. Building the alphabet using a string builder only creates one object, because every time you call that, but the result's the same. The result's the same because every time you call the append method, that's changing the internal string within the string builder class. It's not creating a new object, but behaviorally it's exactly the same. So
Was it creating objects and getting rid of them, is it 27 persistent objects, or is it 27? It creates it, then delete. There's still one at the end.
There's one at the end. So basically, the only one that's persistent is the one that the variable reference is pointing to after you've done all that. Yeah, that's it. So the most of those 26, they get created. The variable points them for a fraction of a second. Yeah, and then it moves on, so they're kind of eligible.
Has that got a performance overhead with it, or is that negligible?
Well, I suppose really it needs sort of dummy demonstrations we're doing, it's kind of negligible really, but you could imagine that if you were doing loads and loads of that, and also multi-threaded, like maybe reading from loads of files or something, you could quite quickly build up thousands of objects in memory. Obviously with this it's negligible, but yeah.
But would you consider that as if you were doing a piece of code, would you consider performance and things like that?
You would really. I think at an enterprise level, yeah, you would. You definitely. And if you had like a code review, lots of string manipulation in a big enterprise application, perhaps multi-threaded, that they would pick up on that. They say, "Oh, you're using strings here, and you're doing loads and loads of manipulation. Wouldn't you be better off using string builder?" Another thing to say about string builder as well. Now, thread safety and threading doesn't come into this exam that we're doing here, but it would do if we were to take the study further. But string builder is not thread safe. There's another class called string buffer, which is almost identical to string builder, but it is thread safe. It just means if in a multi-threaded environment, you can rely on this thing being thread safe, so one thread's not going to change the value of something else. String builder's not thread safe. We don't have to worry about it for the OCA exam because thread safety is not on it, but if you worry about thread safety, you could use string buffer. It'd be slightly less performant than string builder, but it's thread safe. So all the methods we're going through here, they're also applicable to this string buffer as well, but it's not specifically on the exam. String builder is. So that's the append method there. And what it's doing, rather than creating new objects each time, it's dynamically resizing its internal string. And if you look at this string builder, if I go right to the top of the class definition, it has a... well, this is about inheritance here. It extends abstract string builder, so let's go into that. But what you see at the heart of it, that is what's at the heart of it, a char array, an array of characters, and that's its internal representation of a string. So every time you append or do something to it using these methods we're about to look at, it's kind of dynamically changing that. So it's dynamically changing that thing there. If we look at the equivalent in the string class, so again, if I can go to the top of the definition of the string class here, we also have a char array there, the same as in the string builder class. The abstract string builder class there, char value there. We have that in string as well. But here's the key difference: it's final in string. That's what makes it immutable, because once you've set it, you can never change the value of a final variable. So that's the key, like, low-level difference of string builder and string. So anyway, moving on. Let's look at this a bit further. Yeah, and another thing that they want you to know as well is there are different ways of instantiating a string builder. So we've done it there with the no arguments constructor. You can also do it, if I comment that out and uncomment this one, you can actually do it with an integer. What that is, it's the initial capacity of, open the wrong one again, the initial size of that array. So you normally, in the kind of business applications that we're working with, we wouldn't worry too much about it. We'd let Java worry about that. But if you know roughly how big that's going to be, you can size it up front. Either way, it'll keep resizing itself dynamically anyway. But that would work just the same. And there's another one here. So I won't run that one because it works exactly the same as the other one. But there's another one here where you can pass in as a string as a starting point. So we're saying, okay, I want a new string builder. I want this string as its starting point. And obviously then what we do, we wouldn't need that to start with. We'd start at B because we've already got A. So if we were to run that now, it should give us the same result. Yeah, using a string builder there. Oh, it starts at AB. So what did I do there? Builder append A. Oh, there we go. Right, that's a bit strange. Now, why is that acting like that? String builder append A. So what happens if we start with A there? So this actually yeah, so we've got 2 A's there now, which is what I expected. So I'm surprised that if we take that away now, B. Oh, I know what it is. We have to print it once before we even start into that loop there. So what I do, I won't bother doing that. But the reason it's not printing the first one with an A in it is because we haven't done a print before we even enter this. So, but you can see what it's doing. It's building up the same as before.
John, what's the point in sizing it dynamically?
Yeah. So we talked about immutability last time, and what we've got here, if you remember, our string up here, we built it so that it's now A to Z. So our string is A to Z, and here we're saying concatenate to it numbers 0 to 9, and if we print that, but if we so we've got string that was A to Z, and we're doing string concat all these numbers. So if we actually print that, you might expect it to be A to Z plus all those numbers, but it's not, and that again demonstrates the immutability of strings, because what this does is it creates a new object, alright, so you create the object on the heap that has the value A to Z, then 0 to 9, but nothing's pointing at it. Nothing's pointing at it, so it kind of gets lost. So to actually make that work properly, you'd have to do this. You'd have to reassign it back to itself afterwards, like that. It demonstrates immutability in the same way that the string tester class did last week. Now it works, but so that's string. But here's the difference, because with a string builder or string buffer, but string builder, we're going to do exactly the same thing here. This string builder starts here as like a to Z alphabet, and we're doing string builder append 0 to 9 to it, and then we're printing it. And this time it does retain that. So what you could do an explicit reassignment like that, but you don't have to in this case, because it's mutable. You've changed the value in that object itself, and so you know, when you then print the value of it, that object itself has changed. It's not the fact that you've created a new object. That object itself has actually changed. So that is actually redundant in the case of string buffer, because you've just got the one object. Remember, with strings, whenever you do any kind of manipulation, you're suddenly creating more objects. So you have to, as you're creating more objects, you have to make sure you're pointing any pertinent references to them, or otherwise those new objects get lost. So here's a few different methods on string builder, and actually these 4 methods work exactly the same as the equivalent methods in string that we looked at last time. So char at, index of, length, and substring, they're all covered in that string tester class. So quite a simple one here. We've got, so SB is a new string builder. So SB contains a char array representation of that, the word animals. So we're going to substring it here, exactly the same as we did with the string class in the last session. So we're going to say, and if you remember, one of the substring is an overloaded method. It's got various different forms, and we're using the form here where we've got a start index of where to substring from, and an end index. And also we're also chaining this method with uses of the index of method. So that's going to be, so SB index of A, it's going to be 0, because the index of the first occurrence of A there is at position 0. So this is going to be substring starting position 0 and ending position of AL, which is there, position 0, 1, 2, 3, 4. So that's effectively going to be 0 and 4. So you're using one string builder method as inputs to another one. And when we print that out, we'd expect that to therefore be a substring starting there and ending there. So anim, that should print out. Anim, there it is. There's a couple of things we're printing out at the bottom here, which keeps. I'll just comment that out, because it keeps appearing at the bottom there. I think hopefully that's that, hopefully. So yeah, there we go, anim there. So that printed out anim, and then we've got so that's that one. Yeah, then we've got length. So length, like, it just returns you an integer on what the length of the string is. So the length of animals is 7, so we'd expect that to be 7. And char at, so we're saying what is the character at position 6. So the character at position 6 is, so we start 0, 1, 2, 3, 4, 5, 6. So it's S. So then if we put all those together using the plus operator, remember plus just acts like concat. So we're saying, so we'd expect that to be sub, which we've already said is anim, plus the length, which is 7, plus that character, which is S. So we'd expect that to be output there, something like that. That's just basically a demonstration of those methods that are exactly the same as the string method. So, and that sure enough, it does that there. So those methods are exactly the same as string. So this one isn't. This is specific to StringBuilder. So you can insert a substring or a char into another StringBuilder value. So here we're saying insert at position 7 a hyphen. So position 7 is right at the end. So we're going to get a hyphen there. And then again, I'll just run all these together because they're quite similar. Position 0, insert another hyphen, so we're going to end up with that. And position 4, another one. So this position 4 is going to be, well, that's the string before it. So 0, 1, 2, 3, 4. So there. So if we run that, so insert is another method there. Just inserts. So that's the result of that. Delete, again, that's obviously the reverse of insert. So we're going to delete. So what this one does is again, this is most of these methods are overloaded. What that means is there's different versions of them. So this version of the delete method takes a start and an end index. So start at position 1 and end at position 3. So it's going to delete BC there. So we'll end up with that string, but with B and C removed from it. And delete char at, well, it's just, you can imagine, deleting the char at a certain position. So if we do that now, we're deleting, so we've got this as what we're currently working at. So 0, 1, 2, 3, 4. So there are 4 positions in it, and we're saying delete char at 5. So any idea what might happen if we do that? I'll run it. Just does throw an exception, and it's a string index out of bounds exception because we're trying to delete a character that's not there. But so if we do 3 instead, then we should be okay. And it does. It's that didn't throw an exception, but we just didn't print it. So there we go, ADE there. So we've deleted the final character. The next one is reverse. So we can just reverse. So we've got ABC. We're just reversing the order of those. So that's fairly straightforward one there. ABC becomes CBA. Now ToString. Now this is an interesting one. This is because ToString. Well, let's just do it first of all. So what we're saying is take SB, and at the point where we are here in the program, SB is equal to that. So we're saying return me a string. So take I'm currently a string buffer, but return me a string. So convert that string buffer into a string. So just run that quickly, and there it is. It's returned it as a string. And what we can do, we can go into that ToString method there on the string buffer, and what you can see is it's creating a new string and just passing it its own char array there. And these various other, again, this string constructor is overloaded. There's lots of different versions of the string constructor. But effectively what it's doing, it's creating a new string object, passing in its own character array. So that's what that's doing there. And object. I've just got some notes to myself here. Yeah. Okay. I think we've done that. So now what we can do, if you remember that last week we tested equality in strings, and so what we've got here is we're creating two string builder objects on the heap. One called 1, one called 2, and they both say hello. So what we've done on the heap, we've actually created two objects. There's two objects there, and they've both got a different reference. So they've both got different reference on the heap. Two objects there, and so when we call the equals method, what we're actually asking is, are these exactly the same object? Are the two object references pointing to the same object? And they're clearly not. They're not pointing to the same object, so you'd expect that to be false, because you've created two. And if you want to know how many objects you've created, just look for that word there, new. Because when using objects, whenever you call that new word, you create an object on the heap. So two objects on the heap, two references, so they're not equal, because this equals operator checks for equality, and when it checks for object equality, it checks, are you literally pointing to the same object? That's the only way you can get a true there. So that's false.
Is there an equivalent to compare the contents?
Yeah. Okay.
Don't worry about it. Just wondered.
Well,
to me that was almost saying there's the contents the same, but you're saying it's not. It's
the
same object.
What we did last week, you see, guys, but probably it's probably worth revisiting this actually, because it's quite an important thing to get through here. I think quite early on. Right. So if we look at this, here's this back what we looked at last week, and it's exactly the same here. We're saying. So let me just turn that to string tester here. And what we can do actually, it doesn't quite. Actually, I think it's later on we do it. So we've just added a string, just to compare it. We've added a string to this class here. So we've just tested this for equality, and we got false. We've done the same for strings here. So just run that first of all. Now also here, this is exactly the same scenario. We've created two objects on the heap, and with two variables pointing at them, so 1s and 2s. You don't expect that to return true, because they're pointing to two separate objects. So just run that just to prove that. So I'm running the wrong class there. Just a second. It's string builder test. That's the one. So again, they're both false. But here's the key difference, because when we looked at strings last week, there's a difference between the equals operator and the equals method. And what this does for a string, it basically looks to see if they are meaningfully the same. So it doesn't matter that the object references are different, the contents are the same. So in this case, looking at now, this is 1s, so this is the string one, not the string buffer. I would expect that to return true, and it does. It returns true there. Now you'd think, because string builder is very similar to string, that using the same logic that would also produce true, because if you look at the two string builder objects, they have the same content.
But that's comparing the object references, isn't it?
Yeah. So here we're using the equals method, but actually it's false. So this is a key difference between strings and string buffers. And why is that? Well, if you look at the equals method on string, so this is on string here, you can see, we don't need to talk through every line of code, but you can see that what it's doing is comparing itself is this, with the other string, the thing that's passed in there. And it's basically going through, what this is basically doing is going through every character in that array, comparing it to the one in its own array, and only returning true if everything in it is the same. So it's implemented its own equals method. So what went wrong, if you like, with the string builder one? Well, here, if we look at the equals method on string builder, something strange happens. It doesn't take us to the string builder class, it takes us to the object class. So basically the equals method has a default implementation on the object class, and it basically makes it behave exactly like the equals operator. It makes it behave exactly like the equals operator. It just compares object references. So it's up to the developer of any particular class to implement their own equals method if they want to override that. The developers of the string class did that, and that's the result of it. But for some reason, the developers of the string builder class didn't. I don't know why. I would have expected them to do something similar to what they've done with string, but they didn't. So what you end up doing, you end up just getting the default implementation. It equals only returns true if the two references are pointing to the same object. In other words, it behaves exactly the same as that, as equals there. So
I'm not sure. So in your output there, the top one s equals 2s false. I'm surprised that's come up because that's using the string rather than string builder, isn't it?
So where are we here? So with string builder, the equals method and the equals operator behave in exactly the same way because equals hasn't been overridden, whereas in string it has been. So that's another key thing to look out for there. Okay, so what we've got here. So here's another few things to test, just to hammer home this equals thing. So we're saying, does 1 equal 2? Well, we've actually already tried. We've already done that. That's what this is. We know it's false because they're pointing. It says 1 and 2 are pointing to different objects. 1 and 2. So we know that's false. Just print it to prove that, but we've already done it. 1 add 2 equals 2 is false, and 1 equals, the method equals 2 is also false in the case of a string buffer. It's also false there for the reasons we just explained, because it equals method behaves exactly the same as the equals operator, only in string builder. So now we have this new variable here, this new variable string builder 3, and it points to 1. So it points to the same object that 1 is pointing to. 1 there. So so what you've got one object on the heap, and you've got and you've already got one object pointing to it. Then you say, create me a new variable reference called 3 and point that to the same object as well. And while you're at it, append an A to it. It's better. So append A. So point that variable reference 3 to the same object that the variable reference 1 is pointing to, which is this string builder here, and append an A to it. So, do you think 1 equals 3 now? So this is 3. Well, the thing to look at when looking at equals is the only thing you need to concern yourself with when looking at the equals operators, are they pointing to the same object? And they are. They are. So you'd expect that to produce true. It does. And using the equals method, well, we know that it behaves exactly the same as the equals operator. So again, that's going to produce true. So the thing to remember is that double equals, the equals operator, it's for objects, it's only concerned about whether two variables point to the same actual object on the heap. The equals method, that's open to developers' interpretation. Like, are they meaningfully the same or not, in terms of the value they have. The string that they have overridden that method, in string builder they haven't. So that's another difference there. And if we just go back to this, so that's string builder pretty much done. We go back to the string class again. We talked about the ToString method here. So we looked at the ToString method on the string builder earlier on. We looked at that was one of the ones up here that it returned. There we go, and it just returned a string representation of itself. So if you remember, we looked into that, and it's going to create a new string with a value like that. If we look at the same thing on the string class, so if I run this string, what it's printing all the examples from the last session. So there'll be a load of stuff. I haven't bothered to comment them out. But the final thing it prints is animal. So I say it's because animal was something we did here using the replace method, and we came up with this string animal. So I'm now saying print. I'm now saying ToString. The variable is called replace. The variable is called replace. I'm saying replace ToString. So we've already printed the variable replace there, and this is variable replace ToString. But actually, using ToString is kind of redundant on the string class because the string is a string already. So if you look at that, it just returns itself. So if you call string ToString, it just returns itself. And like the developers have even used the exclamation mark in their comments there. It's already a string. Itself is returned. So it's completely redundant. In other words, with a string, you might as well just do that. Just do replace, because by default it is a string already. It is, so you get the same result animal there. One more method on string which we'll deal with in a minute, because the final thing for today is so we've done strings and string builders. Next thing we move on to arrays. So a bit to do on this one here, and then actually I've opened the wrong class there. I think I've got it open. Yeah, array tester. There we go. So arrays are obviously just a fairly fundamental collection of objects, fairly, I'd say, unsophisticated. The reason I say unsophisticated is because later on we find some rather more sophisticated ways of keeping collections. But arrays are basically a fairly primitive way of having a collection of objects. The good thing is we've already met it because of this string args array that we use in the main method. So we already met that in chapter 1. There's various different arrays we can cover here, like that one, the string args array in the main method. Arrays of primitive data types, int, long, whatever, and arrays of object references. So objects like, string builder that we've just been looking at, and multidimensional arrays. But it's important to remember that arrays are objects. So they might look like primitives sometimes, but behind the scenes an object is created on the heap. But we'll see that. We'll see that later on. So if we look at another thing you need to know as well is what a way of introducing arrays is what is acceptable in the method signature of the main method. So if I just switch to this now and run it, we've just got this string. We are running array tester.java just to show that we're running it. So yeah, we successfully ran it there. So that is so in other words, that is acceptable for the input to the main method string array, and we know that's a standard one here. But here's a few things you might not have realized. The double brackets to indicate an array don't have to be at the start of it. They can be after it if you want to. It's still just as relevant, but we tend to so that still works, but by convention we put those square brackets before the variable name. So that's how you see it, but you can put it after if you want to. Another thing, right, do you think that will work? Anyone? Well,
doesn't it need args as the keyword?
It doesn't have to be called args. It can be called whatever you want, but we call it args by convention. So if somebody really did call it bananas, you'd want to know why, really. But you can call it whatever you want to. So do you think that will work? If we just want to send a single string rather than an array? No. But you notice that it doesn't fail compilation, because that is actually a perfectly valid method signature. It's just it's not the method signature that this program needs to actually run as a program. So it's compiles perfectly well. That's no problem having a main with just a single string argument, but it can't be runnable in itself. So if we try to run that, main method not found. Please define the method as. It explicitly says you need string args there, so that doesn't work. Now, there's one more that you need to know. It doesn't come until chapter 4, but this might surprise people a bit. That's perfectly valid. That's perfectly valid like that. It's basically what we call this construct. It's come in I think it's new in Java 8, or certainly maybe Java 7, but it's fairly new. It's called VARargs, variable arguments. And it's basically, it kind of works as an array, but it's less rigid than an array. It just means I'm going to be sending you strings here, but a variable number of strings. So that tells you I'm going to be sending one string. That tells you I'm going to be sending an array of strings. But that tells you I'm going to be sending some strings that I don't know how many. It could be 1, it could be 0, it could be 100. variable arguments. It kind of works in the same way as that, but there are subtle differences that are dealt with in quite a lot of detail in another chapter. So the main method has this string array because when we run a Java program from the command line, we might want to be passing parameters into it, like, you know, as you said in chapter 1, that might be that you want to initialize, you know, start a server or something. So you might want to pass in an IP address and a port, or you know, some, you know, number of strings you're going to be running. But it's a way of entering, sending arguments into a program before you run it, and that's the reason we don't have just that, because we might want to send more than one. So you have to be able to send as many as you want to. So that's fine. What we can do. So how do you access something out of an array? Well, we still use the square brackets. So if we want to get the first, so I want to get the first thing out of that array. Again, they're indexed from 0. So I'm just going to say, well, okay, so what is the argument at position 0 of my array? So if I run that, I get an index out of bounds exception, array index out of bounds exception. That's because I've run this without sending anything to it. So when you run it from a command line, you obviously pass those in the command line. You do Java, name of your class, then however many arguments you want. But in IntelliJ, you can actually do it through this configuration editor here. So if I go to array tester here, I just have to put like 1, 2, 3 or something like that. So that's going to pass in those arguments at runtime, and that compiles fine now, so that's all right. You can do it the other way as well. You can say, oh, actually, I want to reassign, you know, the value of that to the word John. So you could just, again, you use the same convention. Use the square brackets with the index of the element in it. So that would now be John 2, 3, because I changed the first one. So here's another, now this demonstrates another string method. So if I go to, as I said, in string tester class, there's a method called split. This is covered and demonstrated in the array tester class, which is where we are now. So go back to array tester. So what you can do, you can actually split a string into substrings based on a delimiter. So here we've delimited these with a dot, and we're splitting it with a dot. That double. This, by the way, we just need certain characters. You just need to escape them. There's like certain characters need an escape to be qualified as a regular expression. They need to be escaped, and dot is one of them. So, but don't worry too much about that. I think we do touch on escape sequences and things, regular expressions, right at the end, I think. But so what's that's going to do? It's going to split that on the dot. So we're going to end up with an array of 6 elements like that. Obviously, if we split it on comma, we would end up with an array with just one element, because then that would be the only element. If we just print that just to demonstrate. So when we split it on a comma, there isn't a comma in there. So it goes through this loop. Remember, this is the shortcut version of the for loop. This was covered a couple of sessions ago. The shortcut version. We're saying that for every element in Java Dev's array, give me a string called Java Dev. So when we do it like with a comma delimiter, it only returns 1. But if we do it with a dot delimiter, like a full stop like that, it will, there we go, it prints them, it splits them out into an array. So this demonstrates how you can, do a for loop to get all the elements out of an array like that, the shortcut. We're saying for every element in this array, for each passing of this loop, assign the current element for this loop to the variable Java Dev there. That's what it's doing there. So how to declare arrays? Well, you can declare arrays like that using the square brackets again. But the thing is, and this is kind of a limitation of arrays, and it's why we have more sophisticated structures that we'll deal with in future sessions. You have to size them like that, so they're quite limited. Once you've sized them, if you want to resize them, you have to manipulate them. So it's, they're not dynamic. They don't dynamically resize themselves. So this default numbers, it can only hold 10 positions in there. So like if we were to try and do this, so an integer array, and without sizing it, it doesn't allow it. It says, oh no, we can't. You can't just do it. You know, you're trying to make this dynamic. You have to size it first. So that doesn't allow that. What an arrays do as well is if you don't, so we haven't put anything into that array yet. We've simply said it's an integer array that can hold 10 values. But if we then iterate through it, so this now is more of a traditional for loop here. So I'm saying start my counter at 0 until it gets to the value of default numbers.length. Length, by the way, is property of arrays, so it'll be 10 in this case, and increment each time. Print me the value of what's in there. So for primitives, and integers are primitives, it will always give you the lowest possible value, so 0. And that's the same if you remember back to chapter 2. Primitives will always have a default initialization of the lowest value they could possibly hold. So for integers, that's 0. Just run that, see. So there we go. So all these array elements, they have a default value of 0. So if you just do that, you've already kind of got an array with 10 integers all set to the value of 0, because by default integers are value 0. So to actually set them, you'd have to, you could do, to actually set them, you could do default, sorry, type it there, default numbers, whatever, 2 equals 2, for example, like that. To actually set the value of it itself, and now that's changed. That one there is 2 now. So, okay, different type of X. So this is declaring the arrays with a sizing there, but no values. You can actually declare them like this, like immediately with all the values in them already. So we're saying this integer array called numbers2 is just going to have those 3 values. I'm telling you up front what it is. That's kind of redundant code, this new int. The use of new there shows that we're dealing with an object. There's an object called array or arrays. There's various objects behind the scenes that are being created. But we don't actually need that, really. We can, in a similar way to string, we can just do it without new. We can just say straight away, okay, int numbers, and here are the values. And because you're telling it explicitly, you don't need to put a number in there, because you're telling it explicitly what it is. But again, you can set a value there. So the value at positions 2, it was 0, but we've changed it to 4. Like we said earlier on, you can have the square brackets before the variable name, after. You can have a space between them if you want to, up to you. But the convention is like that. That top one there is the one you should always go for, because it's the convention. It starts to look a bit strange if you do it in strange ways like this. So here we have a char array. So it's an array of chars, and we've initialized it to hello. And if you remember, in StringBuilder and string, they are maintaining their own copy. Actually, it's easier with string to show you this. They maintain their own copy of, let's go to the top, of a char array. So there it is. So it's final in the case of string because it's immutable. So we've got one here ourselves, and what we could do, we could manipulate that ourselves if we wanted. We could append things to it, we could like chop it in two, we could add things, we could insert things, but we just purely on native methods that we do ourselves that are dealing with this array, using assigning like that. We could assign things like that, or we could chop this off, or we could reassign. But the reason we don't have to is because the string, that's exactly what the string and StringBuilder classes do for us. We don't really have to manipulate arrays of chars, because that's exactly what these classes are all about here. So another thing to say as well is that if I were to print that char array here, it gives a slightly unexpected output, because you might expect it to print hello. It doesn't. It prints its object reference. So if you don't explicitly override the ToString method, it will just give you the object reference of that object on memory, because when you do a print, what you're implicitly doing, sorry, is calling the ToString method on the object. So what you'd actually, to actually print the word hello, you just set up a for loop and do it like that. Shortcut for a loop like that. That does it. So that prints out hello. Like that. So array references can be pointed at other arrays. So we've got an array of bugs here, and we're saying, so we've got two object references. One's called bugs, and it's pointing to this. Then we're creating another one, and we're just pointing it straight to bugs. So one object on the heap, it's an array of strings, but two variable references both pointing to the same thing. And so again, if we check, are they the same? Are they equal? They are. They're equal because they're both pointing to the same object, and they both got the same contents. Here's another one. So arrays can be cast to arrays of other types. Yes. So what we've got here, we've got a string array called string value. So it's quite legitimate to say, okay, create me an object array and point it to strings, because strings are objects, because the superclass of string is object. I was going to go and show you that, because you don't explicitly have to extend object, it's done implicitly. So it's quite okay to say that so it's quite okay to point an object array at a string array, but you can't do it the other way around. You can't say, okay, here's a string array, point it to my object array. You can't do that. But what you can do is you can do it through casting. So here I'm saying I want a new string array, and I want it to point to this object array, and I know what I'm doing. I know that only contains strings, so I'm telling you, the JVM, to just believe me when I tell you that's a string array. So you're explicitly casting there, and explicitly casting is a dangerous thing to do unless you're absolutely sure of yourself, because the JVM will allow you to do it, but if at runtime that didn't happen to be a string array there, that was pointing to ints or something, you get a runtime exception. And what I can do here is, that's another failed one, because I'm saying that, again, strings, so strings, this is a string array, I'm trying to say in position 0, put a string builder in there, but we can't do that, it's the wrong type. So, okay, so we can, length is an array property, so we can say, what's the length of this array that we just created? Well, it's clearly 3, and there it is, 3 there. And here we're printing, printing individual positions, just individual positions in that array. So you can access them through the index there, square brackets with the index. So fairly standard stuff there. Prints them all out. So what we said with a primitive array is that when you, like we had our array of ints, and it gave them, all those ints, a default value of 0. Well, it's very similar with objects. This is an object array here. It's an array of strings. I'm going to call it birds, and we haven't put any objects in it yet. So when we go through and print them out, it's going to get the default value of whatever an object is, and that's null. Section. Let's see, we've got, another thing here as well is that we're trying to access an element that's outside the bounds of the array, because that's only got 3 elements, and we're trying to print the 4th one, so that's array index out of bounds there. So if you try to access an array element that's not within the bounds of what you said it's going to be, you get an array index out of bounds exception there. Just going back to that previous example. Yeah, so these birds here in this birds array, they're all defaulted to a value of null. So objects all get the default value of null. Again, that's something from chapter 1. And yeah, we've already shown that with numbers they get the default value of 0. But obviously we can. here we're incrementing it by 5 each time. So here we're creating an array 10 size 10, and we're assigning the value of it to the value of the index plus 5. So the first one's going to be 5, 6, 7, etc. So that's how we've set the values in that array, then we're printing them. So the other thing is that arrays are sortable. So so what you can do, we've got an integer array here with 691 in it. Now here is a class called Arrays. So this is like a utility, a class that you can use with arrays. So we're saying arrays sort, and you can pass any array you want to into there. So if we print that, so what it's done, it's sorted them numerically because it's realised that they're integers, so it's sorted them numerically into 1, 6, and 9. But what we've got here is we've got a string array here, and we're also going to sort this one. So here we've sorted the numbers one, here we've sorted the strings one, and we're going to print it again, 10, 9, 100. So you might expect that to print 9, 10, 100, but it doesn't, because here we're dealing with strings. So it sorts them with a string mindset. So the character 1 comes before character 9. These are sorted with respect to strings. Of course, if they're integers, they're to be sorted differently. Arrays are also searchable, but so in other words, you can find an element in an array. But one thing to remember is that for arrays to be searchable, they really have to be sorted first, because this is the sorting. Because to make arrays searchable, you really have to have them in a sorted order first. This is where it's not so sophisticated as some construct like an array list, for example, which is a bit more sophisticated than that. So if we so here we have this array called numbers, which I've initialized as 3, 2, 1, and again we've got this method on this arrays class again, this utility class. We've already seen the sort method. We've got this binarySearch method as well. So we're searching in that array for the value for 1. Where is 1 in that array? Where is 2 in that array? Where is 3 in that array? So 3 calls to that array, and let's see what it gives us. It kind of gives us some nonsense results. -1, -4, 1 doesn't really mean a lot, but all you have to do to correct that is sort them first. So you'll sort that array first, so it'll change the order to 1, 2, 3. Now if we do exactly the same binary search, telling me where is 1 in that, where is 2 in that, where is 3 in that, and it gives meaningful results this time. So 1 is at position 0, 2 is at position 1, 3 is at position 2. So that's arrays are sortable and searchable, and if you're going to do a search, a binary search, you should sort them first. So those two. So this arrays object is a very useful object that's used to it's a utility set of utility methods for arrays, and the two we need to know for the exam are sort and binary search.
So once you've searched, that's persistent.
So the final thing to deal with today is actually multidimensional arrays. So you can use square brackets to show how many dimensions you have. So here we have a 2-dimensional array, and each dimension has 3 in it. What I would say is in business applications, you'd rarely use these really. You'd rarely model things in multiple dimensions. You certainly might in physics or maths. These things are probably quite useful. But I would say that if you start to use multi-dimensional arrays to model things in a business application, like for example the zoo class we've got, you could have an array of zoos, and that array, each of those zoos has an array of animals, and each of those animals has an array of properties. It's probably better to actually just create custom objects to model that rather than using multi-dimensional arrays. But let's just go with it just to explain what it is. So what we're saying here is that we've got an array of strings of size 3, and then we've got an array to put that in. So in other words, we could have 3 arrays of strings of size 3, and each of those would itself go in an array. So you've got an array of arrays of strings, and the size of 3 in each dimension. The way you can see that is that, so in the individual elements of that array, so if you want to actually, so these are going to be birds. We've got like garden birds, birds of prey, and domestic birds. So so to set the value of an actual bird, you have to use both dimensions of the array. So you're saying here in the first array, position 1 is going to be a robin, or position 0, position 1 blackbird, position 2 thrush, etc. Then in the second array, you put the birds of prey, and then the domestic birds, etc., etc. And what this demonstrates is that you can then iterate through both dimensions of this. So we're using int I to iterate through the outer array, and j the inner array. You can like iterate through them just to see what the values of those are. So this is a nested for loop, and there we go, it prints all those arrays out. So basically, you know that on the outer level we know we've got three arrays, so that's going to happen 3 times, and then once you're inside any particular one, we know that each of them also have 3 positions, so the inner one is also going to print 3 times. So you end up with 3 printouts, each with 3 values in it. And this is exactly the same as the above, but this time you're using this shortcut for loop here. Exactly the same though. Here we're using the traditional for loop, and here we're using like the shortcut for loop here. And we're going into the loop once to the inner array, then we're going into the outer array, then into the inner array here. Exactly the same results. So what you can do, so here I've created a brand new one-dimensional array of birds of prey. So kestrel, vulture, buzzard instead of what it was before, hawk, eagle, falcon. So what I can do once I've created that, I can actually put that in birds multi-position 1. So birds multi-position 1 previously was all that lot. As you can see, it's position 1 of the outer array because it's there. So we're just overwriting it with that. And if I wanted to set, then reset the name of an individual bird in that, so birds multi, I could do, okay, well actually I don't want that one, so I don't want that vulture anymore. Like that. So that's how you'd set the individual bird again, but you can't do that because the first dimension is expecting, it's saying no, you can't put a string in that position, you need to pass me an array of strings. So it's all about understanding like where you are in that a multi-dimensional array. You can nearly there now, I guess. You can actually initialize multi-dimensional arrays in the same way. If you remember, we did some just one-dimensional arrays where we gave the values straight away. And you can do the same things with multi-dimensional arrays. You're saying here's an array of arrays of ints, and here are the values straight up. That's the first array, that's the second array, that's the third array there. And you can also say, well, here's a multi-array of type int, and you're just saying, well, you're actually explicitly telling it, well, what I want at position 0 of the outer array is a new single dimensional array. So again, you have to stick to what you've told it up front. You can't do that, for example, because it's saying, oh no, this multi-array doesn't accept arrays of strings, it only accepts arrays of ints. So like this one. Again, this is just showing what we've already shown. You can set individual values at the lower level of the inner array just by giving both dimensions. The final, and again, if I were to run that, this particular array doesn't have a position 5 in it, so that will give another array index out of bounds exception. You have to keep to the limits of what you've sized your array to. So you have to keep that in mind. Final thing, absolute final thing today, is that these are all valid declarations of multi-dimensional arrays. That's fairly straightforward. That's what we've already dealt with there, where you have the 2 square brackets before the variable name. This is multi-variable declaration. We saw that in chapter 1. So here we're going to end up with 2 two-dimensional arrays. We're just saving ourselves some typing. Array 2 or something. So that's 3 now. 3 arrays all declared at the same time. That's fine as well. As we said before in the main method, you can put the square brackets after the variable name. This, bizarrely, is also valid, but you wouldn't want to use it really because it's just confusing. You can put, for a 2-dimensional array, you can put 1 of the dimensions there and 1 there if you want to, but it would be very confusing on anyone reading your code to do that. And finally, it is in the book, but it's ridiculous, but it's in the book, so we have to know it. So here we're declaring a 2D and a 3D array. So here's the first dimension. You're saying, okay, I've got 1 dimension already. Vars 4 has a second dimension. So I've declared Vars 4 as a 2-dimensional array. Space, it has that one, and then it's adding 2. So here you're declaring a 2-dimensional and a 3-dimensional array altogether. Not that you ever would, I hope, but you can do it. I think it might throw a few. I very much doubt in an exam they would question your knowledge on this or ask you to manipulate these things. Very likely what they might do is are these valid array declarations, and just show some of these things. But if they actually ask you to do manipulations on them, that would be very, very cruel indeed. I don't think they'd do that. So thanks a lot for coming, guys. Sorry this session's been quite a long one. And so to finish chapter 3, we'll look at array lists and the new date time API in the next session.